So we've worked through almost all of our factoring techniques at this time. We only have one more technique that we need to talk about. Now this technique isn't an official technique. It doesn't have any name to go along with it like most of them that we've seen so far, but we do need to talk about it because it will probably pop up when you least expect it. So I want to pinpoint it now so when you do see it, it doesn't throw you for a loop. And this technique is factoring out negatives. So we see in example 1 here, it looks like our typical polynomial with one exception. Almost always our polynomials have a positive leading term, meaning the highest degree or the highest exponent is positive. If it doesn't fit that mold, then what I suggest to you is factor out the negatives, and then it's going to be an easier factoring process from there on out. Now you can factor it without factoring out the negatives, but I think it's going to be more difficult than just doing this step first. So let's go ahead and work it through on example 1. What we want to do is we want to take this negative out. So I take a negative out of all of my terms in this polynomial. So basically we're just switching all of the signs. If I had a negative 4y squared, that will leave me a positive 4y squared. If I had a negative 8y, that will leave me a positive 8y. And if I had a positive 12, that changes it to a negative 12. Now notice here I factored the negative and I switched all my signs, but I forgot to do my official first rule. I should always look for common factors first. So once I'm looking at this set of parentheses here, I'm noticing that I have a common factor in there. So not only should I have factored out a negative, but I also should have factored out a 4. So let me redo this by factoring out a negative 4. That leaves me with a y squared plus 2y minus 3. Now I have factored out a negative and I factored out my common factor. But I might as well see if I can keep factoring it. If I look inside my parentheses, I have a trinomial. So let's go ahead and try and factor that trinomial. So setting up my two sets of parentheses to unfoil it, y times y will give me y squared, and 3 times 1 will give me 3. My outside gives me a 1y, my inside gives me a 3y, and I want to combine that to give me my middle term here of 2y. And I can make that work if my 3 is positive and my 1 is negative. So make my 3 positive and my 1 negative. So I have factored example 1 completely by starting it by factoring out a negative. Don't forget you can always check any factoring by multiplying it back out. And if you'd like, I suggest you pause the video to try and do that now. So let's go ahead and switch over to example 2. Well, if I look at the first guy, it doesn't look like I have any negatives. So why is this example here in the first place? Well, I need to look at this overall rather than just focusing on my first term. Notice it's not in proper polynomial order. Notice it's not in descending order. So the first thing that I should do is rearrange it and note that any sign in front of the term sticks with that same term. So that gives me a negative 6x squared, a positive x, and a positive 12. So now I've put my polynomial in descending order, and notice it does have a negative with the leading term. So at this time I suggest that you pause the video and see if you can finish factoring this guy on your own. So my first step is to factor that negative out, giving me 6x squared minus x minus 12. And then I have a trinomial left over, so let's go ahead and see if I can factor that trinomial. Factors of 6x squared that I'm going to try and start with are 2x and 3x. And factors of 12, I can use 1 and 12, 2 and 6, 3 and 4. Let me try 3 and 4. I have to put my 3 here and my 4 there so they don't violate any common factor rule. Outside gives me an 8x, Inside gives me a 9x. If I'm looking to come up with my middle term of negative x, I want my 9 to be negative and my 8 to be positive. So my 9 is from a negative and my 8 is from a positive. So I believe that I have factored this one completely. So there is my final answer to example 2. And we worked a couple examples of factoring out negatives. So in example 1, it was obvious that I needed to factor out that negative because it was right there. In example 2, I needed to make sure to rewrite it in descending order, and then it became obvious that I needed to factor out the negative. Just note that when you factor out the negative, it switches all of the signs of your polynomial.